Hello, in this video I'll be introducing you to the standard deviation and the variance of our sets of data. Now this is just a measure of spread, so how spread out our data is. And currently the way we can measure this is by using the range and the interquartile range. But neither of these takes into account all of our pieces of data, and so this is why the standard deviation is so useful. So I'll timestamp the different parts of this video below, and if it is useful please do like and subscribe. So let's start by looking at the standard deviation. Now that's calculated by seeing on average how far away each data value is from the mean. Okay, so let's look at an example now of calculating it. So you can see here I've got 5 different plants and I've written a list here of their heights. Okay, so to calculate the standard deviation, the first thing I'm going to do is find the mean height of the plants. So to do that I need to find x bar. Okay, and that's going to be all of their heights summed together. So their heights are 40 plus 50 plus 20 plus 40 plus 30. And I'm going to divide that by how many plants I have, which is 5. And this gives me a mean height of 36 centimeters. So let me add that onto this picture here. So the mean height is this line, which I'll call x bar. So to find the standard deviation, I now want to find how far away each plant is from that mean, and then find the average of those distances. So I'm going to do that by adding a new column to this thing here and creating a table. So to find the distance away from the mean, I'm going to take each plant's height, which is x, and subtract the mean from it. So we've got 40, subtract the mean, which is 36, and so we get 4. I've got 50, subtract 36, which is 14. 20, subtract 36, which is negative 16. 40, subtract 36, which is 4. And finally 30, subtract 36, which is negative 6. So now we're going to find the average distance away. So we're going to sum all of these distances away together. So I'm going to do 4 plus 14 plus negative 16 plus 4 plus negative 6. And then divide that by how many plants we had, which was 5, and if we calculate this we're going to get 0 divided by 5. So this is saying that on average each plant is 0 centimeters away from the mean. Well, if we have a look, that's clearly not the case. And so you'll always find when you do the difference between each data value and the mean and you sum them together, you'll always get 0, okay? And that's because the values are cancelling each other out, and you could do an algebraic example and see that this will always be the case. And so to fix this, what we do is rather than calculating the mean, we calculate what we call the quadratic mean. So all this is we take the difference, so x minus x bar, and we square it. And that gets rid of these negatives, and it makes it so that we don't get an answer of 0. So I'm going to do 4 squared, which is 16, 14 squared, which is 196, 16 squared, which is 256, 4 squared, which is 16, and negative 6 squared, which is 36. We're now going to find the mean from this. So what we're doing is we're taking the sum of these squared values, so x minus x bar squared, and then dividing this by the number of data values. And so if we calculate this, okay, we're going to do 16 plus 196 plus 256 plus 16 plus 36, which is 520. And then I'm dividing this by 5, and I get an answer of 104. But then if we think about this again in the context of the question, well, each plant isn't 104 centimeters away from the mean, because that just doesn't make any sense at all. So if we look at what we've done, we've actually squared these differences, haven't we? And so to undo this, what we're going to do is square root our answer. So we're going to use the exact same formula, except we're going to take the square root of it, like so. Okay, so we're taking the square root of 104, and if we do this, let me calculate it, the square root of 104, we get to one decimal place 10.2 centimeters, which actually seems to be a lot better. So on average, each plant is about 10.2 centimeters away from the mean. Now we call this calculation that I'll highlight, this one here, we call this our standard deviation. And we can use the lowercase sigma to denote the standard deviation of our data. And we call the formula above it, so this one here, the one that hasn't been square rooted, we call this sigma squared. Okay? And another name for that is the variance of our data. Now both the variance and the standard deviation are both measures of spread of our data. And you might be thinking that's quite a lot of work to calculate these. Well, you can actually use your calculator, okay, to calculate both the variance and standard deviation, and I'll look at that in a later video. And there's also an alternative formula to calculate the standard deviation to this one here, okay? And again, I will look at that in my next video. So hopefully this was useful. If it was, please do like and subscribe, and go over to my channel where I have loads of other maths tutorials. Thanks for watching.